Cuando quieras, Mateo, yo creo que ya puedes empezar, ya se están conectando todos.
Vale,
Recording has started.
entonces,
This
bueno,
meeting is being broadcast on Facebook Live.
ok, entonces buenos días a todos. Es para mí un placer de presentar hoy al doctor François Bourrin, que fue mi director de tesis en Francia. Desde 2009, François es profesor adjunto de oceanografía costera y sedimentología en la Universidad de Perpignan, al sur de Francia. Y sus actividades de investigación se centran en el estudio, la cuantificación y la caracterización de los flujos de materia particulada en diferentes interfaces del continuo tierra-mar. Es uno de los principales observadores del sistema costero mediante glider en Francia y participa en el Comité Nacional de Planificación de la Observación Costera. También está involucrado en el desarrollo de observación a la escala europea a través del proyecto Jericho. Entonces, muchas gracias, François, para aceptar de compartir y de presentar tu investigación. Además que sabemos que en Francia la hora es un poquito tarde y ahora te dejo presentar y después haremos las preguntas.
Ok, gracias Mateo. Me voy a cambiar de idioma. Thank you for coming for the talk. So I'm François Bourrin from France. I'm going to present you my research area about coastal dynamics using satellites and gliders in Dead Sea. So just a few words about my university and about me in France. I'm working at the University of Perpignan. It's a small town of about 200,000 people. This is the southernmost university in France, at the boundary between France and Spain. It's very close to Barcelona, 200 kilometers north of Barcelona. There is about 9,500 students in various areas: human, social sciences, law, management, sports, tourism, and exact sciences, of course. And I'm working in the lab of CEFREM. CEFREM, this is a Center for Formation and Research on Mediterranean Environments. We are about 20 researchers and lecturers, of course, and about 20 PhD students, tenure tracks, and postdocs working together in the lab of CEFREM. This is a small lab in France compared to other labs. We have a pluridisciplinary research team working on the land-to-sea continuum. We are mainly three groups working in geochemistry, oceanography, and another one in ecology, biology, and another one in marine geology and sedimentology. But we have two main teams working together on a continuum from the land to the coast, and to the coast to the open ocean. And the main area we are working on is the Mediterranean Sea. So I will speak about it later. A few words about me. Yes, I have a background in biology and earth sciences, and a master and PhD in oceanography. And I'm assistant professor since 2009 at the University of Perpignan. My current research are focused on particle dynamics, and especially on the role of flocculation of the small particles entering in the ocean. And I'm also interested by the impact of intense meteorological events on sediment fluxes at the interface between the land and the ocean, and also by the anthropogenic and to decorrelate the anthropogenic and natural effects on the shelf sedimentation. My current research fieldwork are located mainly in the Mediterranean Sea, but I'm so interested. I did some fieldwork also in a more polar area, like in the Arctic, and also in South America, in Ushuaia, and we just get a new project in the French island in the middle the Austral Ocean at 60 degrees south in Kerguelen to measure the impact of river fluxes on the Austral Ocean. So it's another project, but I won't speak about it today. So if you want to know more on my activities and papers, you can go to my website on the CEFREM in France. It's it's in English, yeah. So I'm interested mainly by the coastal dynamics. The coastal area it's a very interesting area. This is a critical zone with a lot of population, a lot of coastal ocean use and users, and it's a high sensitive area due to the global change and also anthropogenic activities. We are interested by coastal processes like the land-to-sea transfer of water, of course, and particulate matter, and the carbon sequestration on the shelf. And in this area, all of the fluxes are mainly occurring during extreme events such as flash floods, storms. So we are interested by those brief and violent events. And we are mainly interested by the particulate matter, which is a complex of sediments and organics, but is also the vector of contaminants such as metals. So it's very important to measure those fluxes and especially the particulate matter in the coastal area. So how to study coastal dynamics? We need some instrumentation and we need some platforms. We are using moorings such as buoys, but there are some limitations. We can have some high frequency measurements, but we have low spatial resolution, especially if you have only one mooring. So you have to have many moorings to resolve the spatial resolution at the scale of the coastal area. We are using also some research vessels and boats, but it's very difficult, as you can see on your right. It's very difficult to use them during extreme events, especially in rough sea. And we are interested by storms and flash floods, so every time we have some difficulties to go at sea. We are also using some satellites, but during such events like storms and floods, we have limitation by cloud coverage. So we need more measurements during extreme events, more autonomous measurements at low cost and at various spatio-temporal scales. So the state is that we need another platforms to study those events to resolve the spatial and temporal scales we need. So we decided maybe 10 years ago to use some gliders. You know, maybe everybody knows what's a glider, but we are very interested by using coastal gliders. And here, this is a glider we are using now. The French manufacturer Alcima, maybe you know the name, Sea Explorer. We are doing typical mission of 1 or 3 months, depending of the sensor we have on board, to do high frequency measurements in the coastal area. We are deploying them during extreme events like floods, storms, especially during the winter time, from November in France to February and April. And we are doing some typical mission from the coast to offshore, from about 30-meter depth to the shelf break, to 200-meter depth. And we really need to put the glider very close to the bottom, at about 1 meter above the bottom, to study the sediment suspension during the storm. And we are also interested by the surface, because there are some river plumes, and we are also interested by the behavior of particles at the surface. So we are using 2 types of gliders. Of course, the Slocum from Web Research, and the coastal one, working from 0 to 200-meter depth. And right now we are using also the Sea Explorer, because it's in French and it's more convenient to use them and to work together very closely with the manufacturer. And there is a new Sea Explorer working from 0 to 1,000-meter depth. equipped with rechargeable batteries also. So this is the way we are doing mission in France with coastal gliders. So just a few words about my research area, the main research area, the Med Sea. This is an average picture, a picture of the average chlorophyllite concentration in the Med Sea. As you can see, there is very low content of chlorophyll in the Med Sea compared to the Atlantic or to the Baltic. It's a very oligotrophic area, but there are some hotspots, especially in the southern part of France, because we have river inputs, inputting some particles and organic matter. So we have some hotspots in this area, also in Italy, in the Adriatic Sea, but I will speak about the Gulf of Lions, which is the southern part of France, close to the Mediterranean Sea. The Gulf of Lions, this is a good site to study particle dynamics, not especially because it's very close to my institute, but it's a very special area. It's characterized by a microtidal area. There is a wind-driven circulation also, and the shelf is dominated by the inputs of some rivers. The main rivers is the Rhone River, and the shelf, as you can see here on the picture, is from 0 to the shelf break 200 meter depth, and the shelf break is inside by canyons where the water level was lower during the Messinian glacial period. They are corresponding to a river mouth at the shelf break, and now the water level is 200 meter higher than during this period. So we have a very narrow shelf break of about 200 kilometers of length and 100 kilometers of width, and it's characterized by land to sea transfer during floods and storms. Just some picture to have another view of the system. The main tributaries we are interested, of course, by river inputs, like the Rhone River. This is the main tributary, which is inputting about 10 million tons of sediments in the system, and has a seasonal character with a river discharge between 1,000 and 10,000 cubic meters per second. But the Rhone River is inputting about 90% of the total amount of sediments in the Gulf of Lions. So this is the main river in this area, and this is one of the main rivers in the Mediterranean Sea. There are other very small rivers which are torrential systems, like the Tête River close to Perpignan we are interested by. This is another system with a very low discharge, both in liquid and solid discharge, and this is at the exit of the Gulf of Lions. So we are always comparing those systems to have a big river and a small torrential river with different functioning in this area. But as you can see on the map, you can see a river plume coming from the Rhone all along the coast, and this is the entrance of the system, and here you have the exit of the system towards the canyon of the southwest part of the Gulf of Lions. So this is very interesting to work on both systems to have an idea of the whole area. So just to give you some results we get a few years ago to the study of flood events and the characterization of the particles entering in the system. We are interested about the transformation of the particles in the system when the particles are going from the shelf, from the continent to the shelf. So we did an experiment in February 2014 in flooding conditions. It's a very rare condition, especially at the moment, and we deployed some different instrumentation during the flooding condition at 4,000 cubic meters per second. We did a glider survey in this area and also a field campaign on a research boat which was classical instrumentation like CTD, conductivity, temperature, depth, and we are also using some instrumentation to characterize the size and the shape of the particles. Maybe you know some of them as LIST, the laser in situ scattering and transistometry instruments, and also satellites to have a large overview of the system. Just an overview of the advantage to use gliders. You have on the right some picture about hydrology on the system from the inner shelf to the outer shelf. We are doing maybe in one day 10 casts on the shelf between the coastal area to the open ocean, outer shelf. And we did some interpolation, of course, on temperature, salinity, and suspended particulate matter in migrant parameter here. And on the same area, we did some glider survey on the left. And as you can see, we did also interpolation, of course, but you have a very a better characterization of the hydrogen in the water column, both in temperature, salinity, and turbidity. And the thing we don't need interpolation in this case, and we have very detailed view of this area. You can see the plume of the river plume at the surface here, with a strong signal in temperature, with fresh water at the top and turbid water, of course. We can distinguish surface nephaloid layer, and sometimes we can also distinguish a bottom nephaloid layer. This is a turbid layer at the bottom, developed from the input of the river here. So here we can clearly distinguish the advantage of using gliders to have a more detailed view of the system. So we are also using some package to characterize particles. At this time, this is very big instrument, so you can only deploy them from a boat. And we use two types of instrumentation. One is using the laser diffraction to characterize particles and to have an idea of the shape, the size of the particles. This is a LIST 100X. And we are also using another type of LIST. This is a LIST holography to do some picture of the particles. And here you can estimate the complexity of the particles. And from the complexity and other parameters, we are also estimating the settling velocity of the particles, the density of the particles, and to estimate the behavior of the particles in the coastal area. So both instrumentation are very complementary. On the red shape, you have the distribution from the different laser diffraction, and from the blue, you have the shape from the holographic camera. So we did some merging to have a world spectra between about 1 micron to 1 millimeter. So both instruments are interesting to complete and to measure the whole spectra of marine particles in suspension. Few results about observation we did in front of the Rhone River. You have some results from the inner shelf on the left, and you can see that we collected a lot of picture of large aggregates very close to the river walls. And when we are going toward the outside to the open shelf, we have less particles. All the particles were settled on the bottom, and as we go towards the open sea, we have less turbidity and more biological particles. As you can see, we get some copepods and zooplankton. So we had always high proportion of flocks and aggregates at the coast. Particles are finer cirrad, and outside the plume, when you have less turbidity, more light entering in the system, you have more biology outside the plume offshore. So this is one of the results we get from instrumentation. So we also did some glider matchup with satellites in this area. We did some day on return from the coast to the shell break at 200-meter depth. You have the picture here of turbidity coming from OLI and Landsat satellites. And here, this is a comparison between satellites and the glider area. With the satellites, you have only the picture of the surface area, and when you have clouds, of course, you have no data. You can see here, and in front of each picture of satellites, it was from the 4th, 7th, and 11 February from way, return, and way. And we have the high resolution of the dynamics of the plumes, both at the surface and at the bottom from the glider. And if you have clouds, you have data from the glider. That's a great advantage of the glider. So you have different situations. It was during a flood events, the beginning of the floods. Then you have the main input of the river during the floods. So we have both surface layer and the nepheloid layer at the bottom. And just at the end, we had a storm which disrupted the stratification, and we have a link between the surface layer and the nepheloid layer in this case. So, and this is one of the papers my former students Gail Mani in 2018. So we wanted to go further and to characterize particles from both glider and satellites. So we did some in situ measurements of particle size. We derived an index from both optical sensor from gliders, but also from satellites. And we get an index. This is a gamma index. The lower the gamma, the bigger are the particles, and the bigger is the gamma, the lowest, the finer are the particles. And we get a nice correlation between in situ data from the glider and surface reflectance from satellites. And here is the results from this campaign. We compared the data, and we get big particles at the surface in the surface plume, and also in the nepheloid layers, meaning that they are composed of large flocks in this area, and seaward we have finer particles. This is just an index. It's not direct measurements of the particle size, but we confirm the data we get with in situ data from research vessel and laser in situ scattering transmissitometry measurements. We wanted to go also further, and we did another experiment. So this one we implemented on the glider. This one is a slow cum. We implemented a list. It was a collaboration with my colleague in Rutgers, Travis Miles, and we implemented. It was one of the first time we implemented a list on a glider. This is a big instrument, but in collaboration with the Sequoia company and Web Research, we were able to develop subsystem, and we deployed on the same area, but at a different period. It was the third part of the PhD of Mathieu, but he didn't have time to explore, so I have to do it now. But we had some interesting results in this area. I will show you. So here real-time information of hydrology, temperature, salinity, of course, from the glider, from the CTD. We derived also the density and also an index of stratification, buoyancy, frequency. And at the same time, from the list, we can see some motion in the coast area with surface water entering and going downward, and at the same time some mixing in this area, especially close to the plume limit. And at the same time, we get information of the particle size in this area, especially massive concentration of particles. This is a calibration made with a bot. We can have an index here of the D50, the median grain size of the particles, and from the mass concentration, and also the list is giving also a volume concentration of the particles. We can also estimate then the density of the particles. But we were very confident about those data at the same time. So the idea was to extract some spectra of the size of particles in this area, and here you have a spectra in the surface layer and the spectra in the bottom layer, and we figured out that at the surface layer we were able to characterize bigger particles. Here you have the main mode of the spectra, around 200 microns, and in the bottom layer you have, of course, finer particles. That meaning that inside the plumes you have a lot of flocculation of clays and bigger aggregates at the surface than at the bottom. So we get a lot of data, so we still need to analyze them in details. So the idea was to estimate, of course, the settling velocity of the particles for each size classes, for clays and aggregates, and to estimate the behavior of particles on the shelf. And finally, we want to integrate those parameters in hydrosedimentary models and to estimate the behavior of particles on the shelf in the Gulf of Lions. So just a few words about take-home message. So yes, of course, gliders are useful tools to study particle dynamics, especially with the miniaturization of some sensors like LIST. I didn't speak about ADCP because I'm sure Mathieu already did it. It's very important to characterize the particle dynamics during energetic events when you can't go at sea with a boat, so gliders are very useful when you can deploy them before those events. It was very convenient also during COVID conditions because we were not able to go at sea during this period, but we deployed some gliders. You can use a wide range of payloads, ADCP, LIST, camera, everything, and you can do, of course, high frequency measurements at various spatial temporal scales on the shelf. Just a few words about project. We are involved in France and also with colleagues from Spain and Italy, and we are trying to do some to put together all observing systems in Europe inside a research infrastructure, not only by using gliders but also using HF radar, research vessels, coastal buoys, and to do joint efforts in the frame of Europe. And this is an idea to have an integrated infrastructure to observe the coastal area in the Med Sea, but also in Europe. So in the Med Sea we have a very nice network, but this is an idea to expand this solution elsewhere in Europe, and especially in Europe we have some fundings to do this kind of integration. So we're expecting a lot about this. Okay, thank you for your attention, and I will be happy to answer to a question if we have time.
Thank you very much. Question? You can now open your camera or your microphone.
I'm sure Mathieu will have some question about the third part of his PhD he didn't release.
Yes, I
Matthew?
don't know. Yes. Obviously, I have a question, especially about the list, because I don't know really well this instrument. Do you think it's possible to convert the list information in carbon organic units? Because I think it will be really interesting to convert it, to get a sequestration in the coastal area about carbon quantity, something like that. But I don't know if you can do that with relationship, a global relationship, or if there is something like that in the Gulf of Lions, especially for the Gulf of Lions.
Now, in front of river mouths, we have most of the particles are lithogenic, and if you are going to the open ocean, you have more organic particles. But on the glider, we have the list sensor, but also some sensor of turbidity and chlorophyll. So you can do a ratio, and it's done always from profiling plots, and the ratio can indicate the quality of the particles in the water column. Yeah, but not only with the list. The list is you have the size and the transmission. You can have an information of the concentration, but not on the quality.
Okay, thank you.
Now it's very interesting to link the physical forcings and the biogeochemical parameters, of course, especially in the coastal area, but also in the open ocean.
Yes, and I think it will be really interesting to get an ADCP with a list to understand the particle dynamics, but I think it's not possible yet in the same glider.
You need a lot of batteries.
Thank you. More question?
Maybe question in the chat?
Sorry?
No.
The chat, no. In the there are questions in redes network. Alina?
No, no tenemos preguntas. Muchos likes, pero no tenemos preguntas.
Ok. ¿Alguien más quiere preguntar? ¿Está? Ok, pues thank you very much, Doctor François, for the seminar.
Okay, no problem. I'm expecting to maybe to come in Ensenada next.
Oh yes.
Why not? No, Mathieu told me that there is a Mexican geoscience meeting, maybe. No.
Yes.
Like in Europe. Or,
Yes,
in
November.
in November.
In
Yes.
November, see, yes. Yeah.
Yes, you should come. It's in Puerto Vallarta.
Where is it exactly?
That is in the Pacific.
Ah,
Yes.
Pacific.
And I'm sure, I don't know, Enrique, you don't have any questions, Enrique?
Regarding these structures that you found I think was you find a kind of layers, and you show like an arrows, like saying the direction of the movement of these layers, kind of vertical velocity. You are kind of saying that it's occurring there, and I'm wondering what kind of instabilities. If you found some instability at the fronts of these plumes of these strong salinity contrasts, what is the origin of these layers?
Yeah, this is a good question. We are seeing this kind of structure, especially in frontal zone between the coastal current and offshore, and we have some. Here you are speaking about these pictures. Yeah. It depends of course of the wind at the surface, and you can have some kind of upwelling waters coming from the deep also. But we are seeing always the structure in this area. So the main forcing is the wind in this area.
Okay. So it's a kind of like it's called winds. It's like a gravitational instability, or no? It's straight wind erosion, or
No, I'm sure it's a motion from the winds, not from gravity. No, not in this area.
okay. The winds are not colder than the ocean, or how is the temperature of the wind related to the ocean? These winds.
Yeah, we are in this area. We can have some dense water formation also. Especially during the winter.
Okay.
But here the main motion are coming from the wind and the river inputs also. Yeah.
Okay. Yeah, we have observed kind of similar layers on different variables like backscatter, so oxygen, sometimes temperature salinity at the periphery of large eddies. And I was wondering if it was a similar mechanism.
So you have to some kind of mixing between water masses, yeah.
Yeah, I think it's what they call layering. I don't know if you heard about layering.
Yeah.
I think
digit layers, no?
What's that?
Digit layers.
It's like a high pass frequency layers of salinity and temperature. It's because there's vertical shear on the periphery of the eddy, apparently. But very interesting, yeah. We work a little bit in further from the coast, but and we're using gliders. But I work with Mathieu. Right now, so yeah, we're using gliders, but doing like deep oceanography more.
Yeah, no, for sure there are some intermediate layers, nepherid layers, gliding on the density interfaces, of course, yeah, from the coast, and you have some mixing to replace the water coming from downward. Yeah.
Thank you, François.
Anyway.
Thank you very much. More question?
I do have a question.
Okay.
This is Julio Sheinbaum. As part of a project that we did, and it's still going a little bit. We a group of scientists from another institute that actually designed a Mexican glider. So, but it's supposed to be more for coastal, more like the kind of measurements you make. I mean, Enrique, as he was mentioning, we usually work with deep water gliders.
Yeah. So
I don't know if, it's really a general question. I mean, how do you or what's the difference, or what is the recommendations that you may have on using gliders for coastal observations? I mean, it's a really very general question, but I don't know if you have any comments on that. I mean, we have been testing this Mexican glider, and I don't know if Enrique, I don't think they have been very successful. So.
Not really, but yeah, we in the coastal area you need very reactive glider, especially if you want to do some measurements very close to the bottom. So that's why we are using the American one. And on the opposite side, we are working in France to develop some deep glider to go very deep until the limit we want to reach is maybe 5,000 meters. So this is the president in France. He wants to go deeper and to explore more the deep ocean. So it's a new way to do. So the way is now is to go deeper. Yeah.
A presidential order. Yeah.
Yeah.
Well, good luck.
Thank you.
We have a question from the chat of Filippo. François, do you plan to use sediment traps in your project in order to compare these glider measurements, aggregates, and particle size estimates with trap fluxes, or no?
Yeah, we already do that. Yeah, in the French network. Yes, we have some moorings in this area in the canyon, so we are comparing data from the gliders and with moorings in the canyons to estimate the exchange between the shelf and the open ocean. This is one of the main interest in my lab, to use some PPS3 sediment traps and of course estimate sediment fluxes. I mean, during maybe we did it since 1993 in this area. So yes, you can compare, yeah, of course.
And just a comment about the Henry equations about the instability. I think it's a little bit complicated to characterize the instability in the coastal area because, as you know, it's not always the geostrophic balance. So we cannot use geostrophic approximation as it's the case in the open ocean. So if you want to get a precise information, you need to use an ADCP on a glider. And if you have an ADCP, you cannot use a list for particle size. So you need to do a choice about or get a lot of gliders, but it's not the case in France. It's a little bit complicated to get a glider to do a mission. So yes, you need to find a compromise.
So thank you, Mathieu, for inviting me for this talk.
Thank you, François, to present your research, and I'm sure we will speak a lot to continue to work together, and maybe with some people here in the CCC.
Okay, thank you. See you. Bye.
Okay, bye-bye.
Bye.
Thank you very much.
Salud.
Bye.
Bye.
Thanks for everybody.
Saludos.
Bye.
Bye, gracias.
The broadcast of Facebook Live has stopped.